Hear that? Believe it or not, summer is just around the corner. Luckily, Armor All, America's most trusted auto appearance brand, has what your car needs to get that perfect summer shine. Plus, now through May 31st, we'll give you $5 for every $20 you spend on Armor All products. That means car wash pods, protectant, tire shine, you name it. Find out how to get your $5 rebate at armorall.com. Armor All, less work, more clean. Terms apply.
Singletracks is psyched that Jamis Bikes has come on as a supporter of the podcast and is also a supporter of the website. Jamis has been designing and building quality bikes since 1979, and they were among the first to produce mountain bikes beginning in 1982. The brand has brought the world some iconic and award-winning mountain bikes over the past 40 or so years, and the Dragon has been the soul of the brand for decades. Introduced in 1993, the Jamis Dragon Hardtail delivers the feel that only comes with high-quality steel, and it's done so for nearly 30 years running. The newer Jamis Portal and Hardline full suspension bikes feature the innovative and race-proven 3VO suspension platform, built into both carbon and aluminum frame options. You can check out this year's all-new Dragon and 3VO bikes, along with the entire lineup of Jamis high-performance mountain bikes at jamisbikes.com. That's jamisbikes.com. Hey everybody, welcome to the Singletracks podcast. My name is Jeff, and today my guest is Chris Smith. Chris is the USA Marketing Manager for Laser Sport, where he's worked for more than 7 years. And today we're going to be talking about mountain bike helmets. Thanks for joining us, Chris.
Yeah, thanks for having me on. I appreciate the invite and the opportunity to speak with you today.
Awesome. Well, let's talk about the anatomy of a bike helmet, starting at the shell, really. And that's the outer covering of a shell, the most visible part. What's the purpose of this shell? Is it just for looks, or does it have another purpose to it? And what is it typically made out of?
Typically, it's made out of polycarbonate material, basically just plastic. I'm not familiar of another material that other manufacturers might be using. Mm-hmm. Talking specifically about laser products, they all use that polycarbonate material. Okay. Originally, when Giro came out with their their super light helmet back in the late 1980s, their original covering was fabric, but once manufacturers were able to come up with what they call a micro shell, or that very thin polycarbonate shell, mm-hmm. All manufacturers shifted over to using that polycarbonate shell. Mm. And basically, its purpose is really to just protect the EPS foam, or the expanded polystyrene foam, mm-hmm. counts for the majority of the helmet volume, or the majority of the helmet materials. That foam's job is basically to absorb the energy that comes through the helmet in the event of an impact. Mm-hmm. So that polycarbonate shell helps protect that foam from any kind of minor drops or dents, to assure that EPS foam stays as pristine as possible, and ready to do its job in the event of an impact.
Yeah, I mean, it seems like it's just there, it might appear that it's there just to make the helmet look good and shiny and, colorful, but it sounds like it's protecting the EPS, which is protecting your head. And so if you had a helmet without that, like if you rip that protective shell off of the helmet, that wouldn't be a good thing, right? Like you need to replace that helmet at that point, I would guess.
Yeah, absolutely. With that polycarbonate shell, it does give manufacturers the ability to kind of add some style and color to the external part of the helmet. But yes, it does play a very critical role in protecting that EPS foam, and also preventing, again, in the event of an impact, any of that EPS foam from breaking apart or splintering, separating away from the rest of the helmet. So yeah, in addition to protecting that EPS foam against miscellaneous drops or denting, it also plays a role in keeping that foam around the rider's head needs to be in the event of an impact.
Yeah. Well, you mentioned the next layer beneath that, which is the EPS foam, essentially. And to me, it sort of reminds me of like that white styrofoam that you would see like coolers, like cheap coolers made out of in the old days that kind of breaks apart real easily. But this is kind of different from that in that it's much stiffer, more firm. It like holds its shape a lot better. But what makes it such a good material for helmet construction in terms of safety and just the overall like ability for the helmet to keep its shape when you're wearing it?
Well, it's really the best balance between durability, just kind of day-to-day durability. Like you said, the foam that is used in a bicycle helmet is a denser foam than you would see in a polystyrene cooler.
Mm-hmm.
The material is the same. It's both. They're both polystyrene foam. It's a denser foam that is used in bicycle helmets, and you've actually seen laser as an example of that. You've seen manufacturers use different density foams depending upon where in the helmet that foam is going to be positioned. So in areas of high likelihood of impact, they'll use the denser foam. But in areas where it's less likely to have an impact or where they might look for an opportunity to take advantage of some weight reduction, some manufacturers will use a lighter density foam that actually gets closer to what you would find in that beverage cooler.
Yeah.
So again, it's durable. It's also easy to use, and it does a fantastic job at that energy absorption, so that it will compress and absorb the energy from an impact, as opposed to transferring that energy or the majority of that energy to the rider's head. So it really does a great job in what it's intended to do.
Mm-hmm.
It's also, it's an economical product to use in mass production. So it's durable, it's lightweight, it does the job as far as energy absorption, and it also, in using that material, it helps keep the price down, especially on low end and mid price helmets. So it's really a fantastic material to use for this intended purpose.
Yeah. Well, you mentioned manufacturing. Where are most helmets produced these days?
China. The manufacturing facilities in China have been building bicycle helmets for multiple decades at this point, not just for bicycle use, but also other sport use and motorsport products as well. And they're able to use the technology that they developed for other helmet uses and incorporate that into bicycle helmet design. And really, China has kind of some of the most developed and sophisticated helmet manufacturing facilities available in the market now.
Yeah. Yeah. Well, we've talked a lot, and, this may be part of our conversation later about replacing helmets, after a certain amount of time because the materials do break down. And then certainly in the event of a crash, is that EPS material, is it recyclable? Is this something that potentially can be reused, or is it a pretty much like one and done type of material?
No, the polystyrene foam does have the ability to be recycled. To date, it's a fairly expensive and complex process in order to recycle EPS foam. So, to my knowledge, there's nobody that is really offering this on a mass consumer scale yet.
Mm-hmm.
But that's the case for just about any material. Until you really scale it up and develop the ability to recycle materials in high volume, it remains an expensive proposition.
Yeah.
But I expect at some point in the future that the ability to recycle helmets will be available. It's a complicated process because it's not just EPS foam in the helmet. You have the polycarbonate shell. You have materials inside of the foam that are that the foam is kind of expanded around during the manufacturing process. You've got straps and buckles and other pieces those all have to be disassembled somehow before you can recycle all of those individual components. So like I said, it's a complicated process right now, and I'm not aware of anybody doing that at the moment.
Yeah.
But it's certainly possible, and I expect that at some point in the future that'll be available.
Interesting. Well, let's talk a little bit about retention systems and how those work. The part of the retention system that most people are familiar with, like the most visible part, the part we interact with the most, is going to be the chin strap. What's the purpose of that? Is that like the main way that we're keeping the helmet on our head, or is it something else in terms of how the whole system works?
Well, it's doing two things. Number one, as you said, it's keeping the helmet on the top of your head. If you didn't have the chin strap in place, the chances are in an impact, the helmet is going to come off the head and not do the job that it was intended to do. So fundamentally, the straps, the chin buckle, keep the helmet on the rider's head, so that it's there to do its job. But the other important thing to be aware of is that the straps need to be adjusted correctly. The chin buckle needs to be adjusted correctly, so that the helmet not only stays on the rider's head, but stays in the right position in order to protect the head should something go wrong. I advise people to set their helmets up so that the front brim of the helmet sits about a finger's width above the eyebrows. And that there's maybe one or two finger thicknesses underneath the buckle, and to make sure that the straps are adjusted correctly, that don't allow the helmet to have a lot of back and forth movement or side to side movement on the rider's head.
Yeah.
Again, you don't want to have the helmet kind of locked down on the head and not have the ability to open your mouth because the straps are too tight. So you want to balance the kind of the fit of the helmet versus how the straps are adjusted. But keeping the helmet on the rider's head and keeping the helmet in the correct position to do its job are the two roles that the straps and buckle play. And then as far as the retention system, the other part of that is what's going on in the inside of the helmet. All helmets have some kind of adjustment. On a lot of laser helmets, it's on the top surface of the helmet. Most other helmets, it's on the back of the helmet. It is important to adjust the retention system inside the helmet itself, again, so that the helmet doesn't shift on your head just in the normal course of riding, or again, in the event of an impact, that the helmet doesn't dramatically shift positions. And the retention system inside the helmet plays a very important role in that as well. So you kind of want to have the best balance between comfort, which is going to encourage you to keep the helmet on and wear it every ride, because uncomfortable helmets, uncomfortable shoes, it does not make riding pleasurable, and you look for excuses not to wear those items. So you want to make sure that the helmet is set up comfortably so you wear it for every ride, and balance that comfort with the security in fit so that the helmet does its job when called.
Yeah. Well, I know for me personally, I tend to rely a lot on sort of the interior retention system that you're talking about. Basically, the thing that goes kind of around the circumference of your head and kind of keeps it tight so that it's not moving around. Like if you turn your head, it's going to go with your head instead of like kind of jostling around. Do you have other tips? I mean, you mentioned like the finger width test in terms of where the chin strap is. And also obviously making sure that you're comfortable, because you can have too tight of a fit for sure with those retention systems where you're cutting off blood flow to your head and, you start to get a little headache from it. But yeah, what other tips are there for testing a helmet fit, and specifically in terms of making sure you have the right size helmet? Because I know a lot of brands have different sizing systems. None of them are really standardized. So how do you know when you have that like correct fit and the correct size?
Well, it depends where you're buying your helmet. Ideally, it would be in a retail environment where you'd be able to try on different size helmets and helmets from different manufacturers. one of the reasons that there's so many different helmet manufacturers out there is they each are using their own developed retention system inside the helmet. They're using different shapes in the molding of the helmet, which creates a different shape interior or a different volume inside the helmet. Really, the only way to know if the helmet is going to be comfortable is to take it off the wall display and try it on and adjust it and see how it fits on your head.
Mm-hmm.
There's lots of different shaped heads, oval shape, round shape, kind of a balance between the two.
Mm-hmm.
And some helmets are gonna fit better than others. And it's really best to get the helmet on your head and see if there's any pressure points or hot spots once you have the helmet adjusted. And
Mm-hmm.
You'll know pretty quickly once you have the helmet on your head if there's a discomfort issue. Just we all know from experience that if something is uncomfortable in the first few seconds or minutes of trying something on, it's not going to get any better.
Right. Yeah, that's a good point. You don't we break in our shoes, but you don't really break in a helmet so much.
No. Once a helmet is broken in any form, it's hard to replace
Right.
it.
Probably not a good choice of words.
Yeah, but it's not going to get more comfortable if there's a fit issue in the store. As far as sizing goes, I encourage people to get into the smallest size helmet that fits comfortably on their head.
Yeah.
You mentioned kind of different size standards. Some helmets are what's called a unisize, where it only comes in one size and all of the fit is done by the adjustable retention system.
Mm-hmm.
But if you're looking at a helmet that comes in multiple sizes, you want to get into the smallest size helmet that fits on your head. And that's not just fitting on your head, but also at least, like a half to a full turn of the retention mechanism. Because if your head is pushed up against the foam on the helmet, it may affect the foam's ability to absorb that energy. So it's not a problem if there is a gap between the side of your head and where the interior foam starts. So you don't want to be pushing that helmet down on your head and kind of forcing your head into contact with that foam.
Yeah.
So if you can get the helmet comfortably on your head, you can get at least a half to a full turn of the retention mechanism before it starts to tighten up, then you're probably into the right size.
Okay.
If it takes 2, 3, or more turns of the fit system in order to get it to snug up, I would encourage consumers that if there is a smaller size available in that model, that you try on that smaller size and see if it maybe provides a better fit.
Yeah. Yeah. And I guess logically too, you're going to know if a helmet's too small. I mean, basically you can't get it on your head, even with the dials, all the way out and the chin strap at the bottom of it. And then, if one is, you just keep trying them until you find kind of the smallest one that fits. That sounds pretty easy.
Yep. And we, not to blow our own horn, but I'll take the opportunity to mention that we actually offer a satisfaction guarantee with our products, and we give consumers 60 days in our helmet to try it out.
Oh, wow.
And make sure that it's working for them as far as comfort and fit and performance. So as far as our products go, we're pretty confident in the way that we've designed them for comfort and fit, that we can back it up with this guarantee. But consumers might want to check again with their retailer or their online reseller to see if there is any kind of offer for exchange on size or model or brand if what they purchased doesn't happen to work for them.
Yeah. Wow, that's great. Well, let's talk about safety standards. What are the main ones that cover bike helmets and the ones sort of that people should be familiar with?
Well, outside of a complete lack of a safety standard or certification, which really isn't a standard at all, there's 3 testing standards available globally.
Okay.
Helmets need to meet that testing standard in the market that they're sold into. So from the least stringent standard to the most stringent standard, the CE certification is what is used in Europe.
Okay.
The CPSC, or Consumer Product Safety Commission, testing standard and certification is what is used in North America.
Okay.
And then the Australia and New Zealand testing standard is specific to those countries. And again, they have the most stringent testing. They also have a compulsory helmet law. So if you are cycling in Australia or New Zealand, it is against the law to ride without a cycling helmet.
Oh, wow.
So again, the manufacturer has to build the helmet to meet that certification within the country that the helmet is being sold into. And that's why I mentioned earlier, I might have mentioned it before we actually started recording, that if you're buying a helmet at your local retailer, they really don't have access to be able to buy product from a distributor that doesn't meet the certification within their country.
Yeah.
And you can actually see it. There's a sticker inside the helmet that proves that the helmet meets that certification standard within the being sold into. So all the helmets that you'll find at your local retailer here in the United States will have that CPSC certification sticker inside. So unless your retailer is buying product from outside of the United States, you can be pretty confident that the helmet that you're buying at your local bike shop is meeting the certification standard for the United States.
Good. Well, I imagine that those standards you're talking about, the CE and the CPSC, those are bicycle-specific helmet standards.
Correct.
And I know it seems like maybe there are separate standards for like motor vehicles, people riding motorcycles. Is there any advantage? Like, are those helmets safer, or are they really testing them against like different types of impact that you would expect to see riding those two different types of vehicles?
Yeah, well, safe is kind of a loaded word. And when you're talking about certification standards, the thing that it's important to understand is that it's just a generic test that all helmets have to pass.
Okay.
Now, I don't want to say that there's no value to the certification standard, because there absolutely is, because it kind of assures that all manufacturers have to meet this minimum level of what the term that we use is protection. You may quibble about the difference between safety and protection, but we use the word protection, different levels of protection depending upon how the helmet is built and what certification standard it's meeting. But again, consumers should be confident that a helmet that meets that CPSC certification standard meets the requirements set forth in the testing protocol by the Consumer Product Safety Commission. But again, all three of these tests that I mentioned, the CE, CPSC, and Australia, New Zealand, they're basically measuring the amount of energy that comes into the helmet from a straight line or what's called a linear impact.
Okay.
So they put the helmet on a head form. The head form, which is shaped like a human head, has sensors, measuring devices in it, and they'll bring a weight in from a single direction, either on the top or the side of the helmet, a certain amount of weight at a certain speed that impacts the helmet, and then the sensors in the head form will measure how much energy is coming into the rider's head. And again, depending upon the market that the helmet is being sold into, the amount of that energy that is acceptable is specified in the certification test.
Okay.
So that the helmet has to be able to absorb X amount of that energy in order to pass that certification test.
Okay. So yeah, I mean, it sounds like overall these are sort of pass-fail tests that we're talking about. There isn't like this one did better or worse. They're all just acceptable, not acceptable.
Yeah, as far as these three certification tests, you're right. It is exactly a pass-fail test. There's other things that they're testing for, and that is the strap and the chin buckle's ability to keep the helmet on the rider's head if there's an impact that comes from the side of the helmet. And there's other tests that have to be done just to to assure that the product is going to be safe for average consumer use.
Mm-hmm.
But the most important aspect of that certification test is, again, testing to assure that the helmet absorbs a certain amount of energy that's coming into it.
Mm-hmm.
I'm sure you and your audience are familiar with MIPS.
Mm-hmm.
Stands for Multi-Directional Impact Protection System. There's other companies that have come up with alternative to MIPS. And basically what that system is doing is building in the helmet's ability to absorb an impact or energy coming into the helmet from what's called an oblique impact. So it's not a linear; it's a straight line impact. It's an
Mm-hmm.
impact that's coming in at an angle that causes the helmet to undergo a rapid rotation,
Mm-hmm.
very, very short amount of time, fractions of a second. And the risk to the rider in an oblique impact is if the helmet undergoes that rapid rotation, and that helmet rotating forces the head to undergo that same kind of rapid rotation,
Mm-hmm.
it can potentially cause concussion or what's called rotational brain injury, because the brain, is suspended in the fluid inside the skull.
Mm-hmm.
There's a delay in the amount of time between when the head and the skull can rotate and when the brain will catch up with that, and you can cause the brain to impact the inside of the skull and suffer that concussion or rotational brain injury.
Mm-hmm.
So what the MIPS system is doing, what other rotational protection systems are doing, is trying to isolate the head from that rapid helmet rotation in the event of an impact, and either reduce the risk of or eliminate the chance of the rider suffering potential rotational brain injury. The reason I bring that up, number one, is because so many companies are offering this now. It's important for consumers to understand what this technology is and what it does. It's protecting what's inside the skull rather than protecting what's outside the skull or the skull itself. And it's also something that current certification standards are not testing for at all. So CPSE, CE, Australia, New Zealand, none of those address the potential for oblique impact or this rotational injury risk.
Mm-hmm. Yeah.
It is being studied by the organizations that are doing the certification process, and I expect that will be included in the certification standards at some point in the near future.
Mm-hmm. Yeah. Yeah. And I guess that suggests the fact that there aren't testing standards for it yet, that potentially there could be some of them that work, some that don't work at all, some that maybe work better than others. And so, yeah, it is kind of a interesting transitional time where this is something we all kind of agree is important, but we don't yet have the tools to know exactly like sort of what to look for.
Yeah, I should say that there's no governmental certification or testing standard.
Mm-hmm.
There may be some consumers that are aware of this, but Virginia Tech has developed a testing protocol to test helmets for their ability to reduce the risk of concussion or rotational injury.
Mm-hmm.
They have been actively testing helmets for a few years now and ranking them regarding their ability to provide this protection from rotational injury. So if you go on the internet and you search Virginia Tech bicycle helmet ratings, you should go directly to their website, and for all the helmets that they have tested, they publish the test results, and they rate those helmets using a star rating system from 0 stars, which are not recommended, to 5-star, which is their best available testing rating.
Mm-hmm.
So that's definitely something to be aware of. And if you are shopping for a helmet, the company is not providing that information up front. Check and see if it's been tested by Virginia Tech, and see what that star rating is, because that's good information to have.
Yeah, that's a great resource. Well, we're talking about safety a lot here, and obviously that's the main purpose of a helmet. But I think for many riders, just as important, heck, maybe more important, is how the helmet looks. And so what role does that play into helmet design and marketing and all that? If you're able to make a helmet that looks good and is safe, what does that mean? What does that do for people?
Well, it prevents you from being mocked and ridiculed when you go out and walk with friends.
Right. Right.
And it also means that the helmet manufacturer is going to sell more helmets.
Right.
Speaking from personal experience, Laser spent a number of years offering very well designed mountain bike helmets that provided great protection for the rider, frankly, atrocious sales. And the reason was because they did not have the right cosmetic look or the right kind of features built into the helmet that mountain bike riders, trail riders, enduro riders were looking for. So you can offer the safest helmet in the world, but if it doesn't have the look that the consumer wants, along with the safety features, nobody's going to buy it. Nobody's going to wear it.
Yeah.
So there is, and we've come a long way just in the last 2 or 3 years as far as our trail helmets, addressing the cosmetic requirement that consumers are looking for while still providing the protection benefits that our helmets have always had. So you could say that it's not an important feature as far as the performance of the helmet. But realistically, when you're designing any consumer goods, the cosmetic look of that product is of critical importance. I mean, you look at car design, you look at shoe design. These products, yes, they have a fundamental function, but there's also a style or a fashion or a cosmetic expectation on the part of the consumers, justifiably so. They want to feel good and look good in the product that they're using. So, does the look of the helmet actually do anything as far as providing protection? No. But if you're going to design a helmet that offers all the protection and also looks great, that's going to appeal to the consumer market, and you're going to have a more successful product at the end of the day.
Yeah. You hit the nail on the head. I mean, if we all know the saying, you look good, you feel good. And then as mountain bikers, we add on, if you feel good, you ride good. And I think a lot of times mountain bikers tend to be these, we want to see ourselves as sort of individualists and make our own decisions and that kind of thing. And we may say like, oh, I don't really care how that looks. Like, I just want something that performs well. But at the end of the day, I mean, that really drives a lot of everyone's decisions. And so if you don't have a helmet that you think makes you look good, maybe you're not going to wear it as often. Or, like you said, maybe you're part of like a friend group or a rider group that, doesn't wear helmets, and part of the reason is because they don't look good or whatever. And so I could see that like sort of peer pressure playing into it for some younger riders, especially.
Yeah, for sure. And if let's say you have 1,000 mountain bikers in a particular market, and one of them is individualistic and is going to buy product based on performance and protection, they don't care how it looks. Well, that's great. You've sold one helmet and you've missed the opportunity to sell a helmet to 999 other riders. Your business model is flawed, and you're not going to last too long in the market. So you gotta give consumers what they want.
Yeah,
the cosmetics and the expected features are in addition to the protection, it's an important aspect of that for sure.
Yeah. Well, let's talk about some of the things that kind of distinguish mountain bike helmets from helmets for other activities like road biking or, even BMX or things like that. And I want to start with the idea of this like extended rear coverage on half shell helmets. The generally vented helmets. We're not talking full face here, but ones where there's a good bit of coverage on the back of the helmet. What does that do for riders? What kind of is there additional safety involved in that? And what's kind of the idea behind extended coverage on a mountain bike helmet?
Well, comparing to a road helmet, I don't have the exact statistics, but your typical road bike crash is at moderate to high speed.
Okay.
And I'm sorry to say from personal experience, typically what happens in a road bike crash at high speed is you lose a lot of skin,
Mm-hmm.
and your helmet kind of rattles along on the pavement.
Yeah.
High speed skidding, but less severe impacts because
Mm-hmm.
most of your speed is being scrubbed off along with your skin just because of the amount of body contact
Yeah.
on the road. A lot of mountain bike crashing and impacts is a different story. Low speed crashing, going over the bars or dropping off a trail at slow speed.
Mm-hmm.
And in low speed crashing, low speed impacts, the amount of force that's coming into the helmet can be considerably more. And the location that the helmet will come into contact with an object can be a lot more diverse. So again, road bikes, a lot of time it's the side of the helmet, as the rider is sliding, the side of the head is kind of impacting the road surface. Where in trail crashes, the head can make contact with trees, rocks, rock walls, boulders, anything that is standing up off the surface of the ground. You don't have 2 lanes or more of traffic width of the road that you can slide across. There's just a lot more objects that you can come into contact with, and you can come at those objects from a wider variety of direction.
Mm-hmm.
So the specific benefit to kind of that drop down side and back coverage on trail helmets just provides additional protection around the sides and back of your head, so that if you do come off the bike, and going over the bars or a high side crash, and you don't have control over yourself, that wherever your head happens to impact whatever object you might come into contact with, that you do have that additional protection around the sides and the back of your head, so that hopefully the foam will absorb that impact rather than having that impact hit you underneath where a traditional road helmet might end as far as the coverage on the sides and the back of the head.
Yeah. Well, hearing you describe sort of those risks and kind of the mode of crashing that mountain bikers have, it sounds like potentially there's going to be impact, all around the head, because you don't know. You hit the top of your head, the back. And so it seems what you're saying is that there's that extended rear coverage. Ideally we would have coverage all around our heads. But that's not practical, right? Like you can't have it come down over your forehead much more without getting into your vision and that sort of thing. And you can't really cover your ears all that easily, again, without it being like a baseball helmet or like something closer to a full face. So the rear is like the best spot to do that.
Yep, precisely. And, by having some of that drop coverage on the sides and the rear, it is naturally going to protect the sides of your head and your ears just by having material that's standing out from the sides or the back of your head. It doesn't necessarily always have to be covered, but just the fact that you have that material on the back of the head, it could help protect the sides of your head because it's more likely that the helmet's going to come into contact with that object. But speaking of full face helmets, you see more and more riders using full face helmets in trail riding or in park riding because full face helmets are getting lighter weight, they're getting better ventilated, and there's requirements in some competitive events that you wear a full face helmet regardless of whether you're going up or you're going down, and manufacturers are responding to that by developing lighter weight full face helmets that have ventilated chin bars and are more comfortable to wear in a variety of terrain, but still offer certified protection for downhill riding and racing.
Yeah, that's One of the things I was going to ask about is sort of trail riders starting to use more full face helmets, wear them on more trail rides. In the past, you would only see these in sort of downhill races, and then you were starting to see it more in enduro. And now, again, people are choosing them for some of their everyday rides. What do you see as sort of the barriers to that in terms of like wider adoption? What are the reasons why you might not want to do a full face helmet, and can that be overcome?
It absolutely can be overcome, and the fact that you're seeing more consumers choosing that product shows that the market is already addressing their concerns, or at least starting to address their concerns. The barrier to date has been weight, ventilation, and what I would call breathability, just the ability to get air into the helmet past the chin bar so you comfortably breathe. The certification, the ASTM-DH certification that full face helmets have to meet in order to be rated for downhill use are pretty stringent. But manufacturers have developed the technology in order to build helmets that meet that certification using lighter weight materials, providing more venting so you get better airflow, and opening up the chin bar so you get the ability to comfortably breathe while still offering that protection. It's obvious that that's the direction that the industry is going. It's not going to be too much longer, if it's not already here, that there's some full face helmets that are as comfortable to wear climbing as they would be wearing for descent, or in place of what we would call a half shell helmet. So
yeah,
it's moving that direction because that's what consumers want in order to have that additional protection.
That's great insight and perspective on that. Just the fact it's not that people have just given up and said, well, I'm just going to be hot and, not be able to see as much, but I really want to be protected. It's actually people choosing it because the helmets are better and they are addressing some of those hurdles people had. And so, yeah, it's not a matter of just wanting to be more safe. It's like we've found a better balance between safety and comfort. And yeah, it sounds like we'll continue to see that improving as well.
Yeah, and I give credit to the manufacturers that are offering full face helmets that are getting more and more comfortable to wear, because again, you can have a helmet that looks great, but if it's too uncomfortable, you're just not going to wear it no matter how good it looks. And the fact that you're seeing more and more of these full face helmets on the trail at the parks, is they look obviously as good as they do. But they're also providing a level of performance that the consumer desires and expects, so that they keep pulling it off their shelf and putting it in their bag as their helmet of choice when they go out and ride. So, I think you continue to see the market address that need seriously and develop better and better products in the years to come to address that desire for additional protection.
Yeah. Well, let's talk about another aspect of mountain bike helmets that sort of lives at that intersection between like the style, but also performance. Why do mountain bike helmets have visors? Is that something that we need more than like road bikers, or is it just a style thing, or what's kind of your take on that?
Yeah, the problem is I come from a road background. So for me,
so you just ripped the visor off of every mountain bike helmet you ever had.
Well, I tell you, I don't ride off-road as much as my coworkers at Shimano ride off-road, and that's due to the fact that I'm based here in Minneapolis versus my colleagues that are either working in Colorado or Southern California. So their access to what I would call true mountain biking conditions are at a level beyond what I have access to. So honestly, when I take my mountain bike out and ride, I just wear a road helmet because I'm.
And that's perfectly okay, right? I mean, some people are confused and they say, oh, like, do I have to have a mountain bike helmet? Is it okay to wear a road helmet on the trail in terms of safety and performance? But yeah, that's okay, right?
It's a certified helmet. it passes the certification test. It doesn't have the drop down extra coverage in the rear or maybe some additional coverage in the sides.
Mm-hmm.
So as a consumer, you need to decide, what is important to you. If you have the ability to invest in multiple helmets specific to a particular discipline, I certainly encourage you to do that. The number of helmet samples that I have is already a bit oppressive. So honestly, if I was gonna ride mountain bike in Colorado or California or somewhere with what I would consider real true mountain bike conditions, I would probably use I would for sure use a traditional trail helmet with the visor. Again, just so I wasn't mocked and ridiculed by the people that I was riding with. Also, having that additional protection would be a benefit. What's the advantage to a visor? Well, I think it's there's a certain cosmetic expectation and look to trail helmets that have to have that. But I think the original purpose was, trail conditions where you could be rapidly going in and out of the sun to keep that sun off your face and preventing your eyes from having to make a rapid adjustment between kind of blowout lighting conditions versus the darker shaded conditions. Perhaps that visor helps keep the sun out of the rider's eye. Also, if you're riding in kind of a claustrophobic trail environment where there's leaves and tree branches and other potential obstacles that are intruding into the trail, that visor may push that stuff out of the way and keeping it eyewear or off your face. So, I mean, that could be why visors were initially incorporated into mountain bike helmets and trail helmets. And now it's just become an expectation and a tradition, like I said, an expectation in the look of that helmet that they have integrated visors built in.
Yeah. I mean, I never think to actually use the visor as a visor personally. Like if I'm riding early in the morning, like sunrise, or you're riding at sunset when the sun's right on the horizon, and if you're in a car, like you fold down the visors, and that's really helpful. But I never think to do that with a mountain bike one, and then it ends up being like in the way when I want to take my sunglasses off and put them somewhere, or goggles or whatever. But yeah, you make a good point that it does provide protection from like branches or things that might be kind of coming into your face from the top and the sides, and kind of using it as a brush guard more than anything else.
Yeah, and I think that, we certainly offer this on a couple of our helmet models. More and more manufacturers are offering some adjustability in that visor. So if you're in a situation where you don't want to use it, you don't have to pull it off the helmet. You could just swing it all the way up and get it out of the way. And then if you're in a situation where you want to keep that sun off your face, or you've got more, trail garbage that's going to come in your face, you can pull that visor down and maybe offer that protection. But I'm all for giving the user more flexibility in the way they set their helmet up, and the best it might work for them. So the more adjustments, the more kind of customization you can have in your helmet, the better, in my opinion. Give the consumer more and let them set it up how it best works for them, rather than asking them to make sacrifices in the product that you're offering them.
For sure. Well, one of the things, visors have been around a long time, and almost every mountain bike helmet has one, and they're designed with safety in mind as well. I mean, they're designed to break away and not impact the helmet's safety features in the event of a crash. On a related note, we see a lot of mountain bikers who mount helmet cameras, lights for riding at night, different things like that on top of their helmets. How does that affect the safety of the helmet, if at all? And do you have any sort of advice for people who are thinking about adding that on to a helmet?
Yeah, I do. Be careful. Helmets are not tested to meet a certification standard with accessories mounted to the helmet. So if you attach a light or a camera to the outside surface of your helmet, at a minimum, you should be aware of the fact that your helmet was not tested, and unless the manufacturer says otherwise, the helmet was not tested to pass a certification standard with that accessory mounted to the helmet. That can affect protection in two different ways. Number one, a potential snag hazard. If you've got a light camera sticking off the top surface of your helmet and you're riding in a trail and something is hanging down the trail that perhaps you miss, you don't get your head ducked down. If it comes onto that accessory and there's no way for that accessory to be ripped off the surface of the helmet, then assuming your helmet is fixed properly to your head, it's going to rip your head back along with the helmet, potentially rip you off your bike.
Yeah, this happened to me many times. I mean, I do a lot of night riding and in trails that are very overgrown. And yeah, I mean, it's happened to me. It's happened to lots of people I ride with for sure. And it does not feel good because you're never expecting it. And yeah, it's very dangerous.
Yeah. So that's the first risk that is involved. Make sure if it's an accessory that you're attaching to your helmet, that there is some way that it can be released from the helmet in a situation that would prevent injury or risk. So eliminate that snag hazard. But the other issue is that you've got an object strapped to the outside of your helmet that can potentially focus an impact into the helmet in a very, very small area, as opposed to that impact being distributed over the surface of the helmet. So, I mean, if you think about it, you know, the entire surface area of the helmet coming into contact with a boulder versus a camera or a light, where the entire force of that impact is directed into the mounting bracket that is fixed to the outside of the helmet, it forces that entire energy to come into the helmet in a very, very small surface area. The helmet was not designed to accept that amount of force coming into that small surface area. The Formula One driver Michael Schumacher was downhill skiing a number of years ago with a action camera affixed to the outside of his ski helmet. And he actually landed on his head, on that helmet, on the action camera, and the accessory mount is what intruded into the interior of the helmet and caused his brain injury.
Wow.
So pretty quickly after that accident, we recognized that risk was only going to grow as accessory light and action camera use got more and more prevalent. So we came out with a helmet that had a system called the safety mounting system, where there was a specific area on the helmet where that bracket was certified to mount, and that area of the helmet had an extra reinforcement on it, so that we could submit that helmet for certification test with the accessory in place and assure that accessory and the mount would not intrude into the interior of the helmet. And to this day, two of our helmets that actually come with an accessory mount as included in the packaging have that reinforced section of the helmet where we specifically call out, you know, where it's safe to mount that accessory. So you either need, as a consumer, to check and make sure that the helmet has been certified to use with that accessory and mount it in the correct spot. Or just accept the fact that the helmet was not designed to offer the protection that would be expected when you have that accessory in place.
Yeah. And I've actually tested, I believe, one of those helmets with the accessory mount. And, you know, you make a good point. You know, it addresses one of the issues, which is that pinpoint sort of, you know, loading or forces, but then you're still like Velcroing on or, you know, screwing down or whatever your helmet light or your helmet camera. And that's still a big snag hazard that people have to be aware of. And so you are taking that risk when you do that. And yeah, there's kind of no way around that.
Yeah. You know what? The accessory that we include is a Velcro mount, and you know, we would hope that the Velcro will tear off and release. Ideally, to prevent that risk. But I mean, if you depending upon the durability and strength of the Velcro, that risk is still there, and that risk is amplified if you're actually physically, mechanically attaching that accessory to the helmet using brackets or screws.
Yeah. Well, Chris, tell us, what does the future of bicycle helmet technology look like, in your opinion?
Well, we spoke to this previously. I think you're going to see more and more manufacturers including some kind of system for rotational brain protection. Historically, helmets have done a great job protecting the exterior of the rider's head, and it's getting more recognizable that they need to do a better job protecting what's inside the rider's head, and consumers are getting more and more educated about this being an important aspect of protection for cycling helmets. So again, I think you're going to see that continue to develop. Certification standards are going to be adjusted to take rotational brain injury into account, reducing that risk, and manufacturers are going to continue to invest in technology and improve the sophistication of helmet design to incorporate that technology in order to reduce that potential risk of injury. Because as you've stated a number of times, helmet's job is to try and protect the rider's head and keep the rider healthy. So that's the primary goal of any helmet company is to assure that they've done everything they can to try and keep their rider protected. In addition to that, I think as the ability to manufacture helmets and use other materials in order to reduce the weight of the helmet or provide better ventilation, or potentially use less non-renewable resources in manufacturing. I think these are all things that manufacturers are going to continue to look at in order to provide the same or better protection using lighter weight, more comfortable products that use less petrochemical materials in manufacturing. So.
Yeah. Well, and it's interesting too, though. I mean, you look at like the materials that are being used, the polystyrene and also the polycarbonate shell, even those are really standard things. I mean, people have been using these for a long time, and almost every helmet uses kind of the same raw materials. But yeah, it's interesting to think about potentially, are there other things out there that work just as well, and that maybe we'll be seeing.
Yep.
Well, finally, I want to ask you, is there one thing that you feel like everyone should know about wearing a bike helmet?
The most important thing we touched on previously, and that is finding a helmet that is comfortable and fits well, because that's going to be a helmet that you're going to grab every time you go out for a ride. Those of us that enjoy riding really look forward to it, but if you have something that is detracting from the enjoyment of your cycling, you're either not going to use it or so. Just take your time when you're shopping for any product that you have a physical interface with: shorts, shoes, gloves, helmet, and just make sure that they fit well and are comfortable in the first few moments after trying them on, because it's not going to get any better the more that you use them. For helmets in particular, you want that thing on your head to do its job in the worst case scenario. And if it's something that actually adds to the enjoyment and benefit of cycling, then chances are it's going to be what you have on your head if you do happen to have a accident.
Right. Yeah, that's great. Well, Chris, thanks so much for taking the time to talk with us. I learned a ton about helmets and how they work and how they're supposed to work. And we appreciate your insight.
Well, thanks for having me on. I enjoyed our discussion, and thanks so much.
Well, you can learn more about some of the helmets in the Laser line at lasersport.com, and we'll have a link to that website in the notes as well. That's all we've got this week. We'll talk to you again next week.